We're going to dive into a real paradox today, one that sits right at the heart of one of public health's greatest success stories. We're going to unpack how the very vaccine that brought polio to its knees has, in some really rare cases, become a source of the disease itself. It's an incredible story of science, setbacks, and a challenge that just won't quit. So that brings us to the big question, right? How can a tool that was designed specifically to prevent polio sometimes, somehow end up causing it? Well, the answer is hiding in the absolutely fascinating and kind of complex world of viral genetics. Okay, so let's jump right into the heart of this thing. For decades, the entire world has been this close to wiping out polio for good, but a really surprising challenge has popped up from inside our own toolkit. So the first thing you need to get your head around is this term, circulating vaccine-derived poliovirus, or cVDPV for short. Now, this isn't the wild polio that we've been fighting for centuries. No, this is a strain that actually starts in the live oral polio vaccine. It mutates, and it can become dangerous all over again, especially when it gets into communities with low vaccination rates. And get this, the scale of the problem is just staggering. About 90% of all of these vaccine-derived outbreaks come from one single source, the type 2 part of the original Sabin oral vaccine. This one tiny vulnerability has turned into a massive roadblock on the path to total eradication. So what is it? What's the scientific flaw that even lets this happen? How does a perfectly safe vaccine manage to revert back into a dangerous virus? Well, it all comes down to the very clever, but as it turns out, imperfect design of that original oral vaccine. And here's the really crucial thing to understand. Whether we're talking about the original naturally occurring wild poliovirus or one of these vaccine-derived strains, the end result can be exactly the same: devastating paralysis. For the person affected, it doesn't matter where the virus came from. See, the magic of the oral polio vaccine, the OPV, is that it uses a live virus. It's been attenuated. That's a sciencey way of saying it's been weakened. So it's too weak to make you sick, but it's strong enough to fire up a really powerful immune response right in your gut. Super effective and really easy to give. But, and this is a big but, here's the catch. As that live, weakened virus makes copies of itself inside the body, it can make little mistakes. You can think of them like genetic typos. Now, over time, if enough of these typos pile up in just the right or, wrong places, they can basically undo the safety features that were built in. And that process, that's called genetic reversion. And this all comes down to a really specific spot in the virus's genetic code, a sort of control panel called the IRES. This is the exact spot where scientists weakened the original virus to make it safe. But it's a delicate balancing act. That exact spot, the key to its safety, is also its Achilles heel. It's the one place where it is most likely to mutate back to its old, dangerous self. So, faced with this incredible challenge, did scientists just throw in the towel? No way. Instead, they went straight back to the drawing board to re-engineer the vaccine from the ground up. The mission? To fix that fundamental flaw and build a better, safer vaccine. And what they came up with is the novel oral polio vaccine type 2, or NOPV2 for short. This time, the goal wasn't just to weaken the virus. It was to make it genetically locked in its safe state, making it way, way harder for it to ever revert back. So how they do it? It was this incredibly precise, almost surgical process. First, they zeroed in on the exact points of instability in that critical iris region. Then, they didn't just make one tiny change. They totally re-engineered the RNA with multiple modifications that work like a series of genetic locks. The end result is a brand new virus that is just incredibly stable. Okay, so you've got this promising new vaccine in the lab. That's one thing. But the real question is, will it actually work out there, in the real world, on a massive scale? Well, what came next was one of the most closely watched public health rollouts in modern history. And when I say massive scale, I mean it. During just its initial emergency use phase, we're talking over 111 million doses of NOPV2 were given out across the globe. This wasn't some small trial. This was a full-on deployment right into the areas that needed it most. And to make sure everything was going right, they set up this unbelievable global surveillance network. They were watching everything. They tracked every single case of paralysis. They were constantly testing sewage to see if the virus was present. And crucially, they genetically sequenced every single poliovirus they found to see if the new vaccine was staying stable. So after all that, months of intense monitoring, millions and millions of doses. The data finally started rolling in. This was the moment of truth. Had the engineers actually pulled it off? Did they succeed in creating a truly stable vaccine? And the single most important number from all of that data? Zero. A big, beautiful zero. Out of 251 samples they analyzed in that first phase, there were 0 reversions at that primary weak spot, that critical site in the IRES where the old vaccine almost always fell apart. And this quote from the CDC just puts it into perspective perfectly. The difference was like night and day. The old vaccine, it reverted in pretty much everyone within just a few days. The new one, it held stable. This was just a huge win for genetic engineering and public health. So the verdict was in, and it was crystal clear. NOPV2 wasn't just some minor upgrade, it was a total game changer, a fundamentally more stable, and because of that, a much safer tool to finally finish the job of eradicating polio. But, and you knew there was a but coming, right? Just because you have a better tool doesn't mean the old problems just disappear overnight. The strains of vaccine-derived poliovirus that were already out there, well, they're still circulating, and they still pose a serious threat. And the thing is, these legacy cVDPV strains, well, they don't care about borders. In our totally connected world, a virus that's circulating in one country can show up in another in just a matter of hours. And a case in Spain really brought that home. So how in the world do you prove that connection? Well, scientists have this amazing tool, a phylogenetic tree. Think of it like a genetic family tree for viruses. By comparing the virus from the patient in Spain to a huge global database, they found a near-perfect match to a strain they already knew was circulating in Senegal. It was like an undeniable genetic fingerprint. And this timeline right here, it just shows you the long, dangerous journey of just one of these rogue strains. It all started with a single vaccine dose way back in 2015. For years, it just spread silently, mutating, evolving. By 2021, it was strong enough to cause paralysis, and it had already crossed continents. This is the kind of persistent threat we're still up against. And that really brings us to the final critical point. We now have this incredible new tool, NOPV2, but these older legacy viruses are still out there. The final battle against polio isn't going to be won by technology alone. It's going to come down to relentless human effort, that global surveillance and the vaccination campaigns that are needed to track down and stamp out every last threat. The endgame is finally in sight, but actually winning it, that's up to us.